Okay, so what I want to look at here, I want to talk to you. I want to talk to you about matrices. I want to just give you a little introduction to what they mean, what they look like, and then after we kind of see how they work a little bit, I'll show you how to use your calculator to build matrices, enter matrices, and do operations with them. We're going to take the next. Oh, that's fine. We're going to take the next few days that we're in here. We're going to talk about how to do operations, arithmetic operations, adding, subtracting, multiplying, dividing matrices. And then we'll look at a couple other little properties and little other bizarre operations we can do with matrices that are important to be able to know how to do. And then ultimately, you'll kind of see why we're doing this. Right now, you don't really know yet. I mean, I think I may have told you, but just consider this something, a new introduction to a new topic that we haven't really spent any time on. Magically, this will have an impact on the stuff that you're already doing in chapter 3 a little bit here soon. But for now, you won't know why, and that's okay.
Of course.
Okay, go ahead, quick.
I just finished all my stuff in PowerPoint one time, so later.
That's fine. Yeah, that's fine. So, what are they? Okay, matrices look like this. Matrices are just a bunch of numbers. Now, they could be variables, but for us, they're typically just going to be numbers. So all these little a sub 1, 1, a sub 1, 2, etc., those stand for numbers, and I'll tell you what they mean in a second. But they're going to be enclosed in square brackets. That's the look of a matrix. So these could skip all the way down. The matrix could have one row, could have 2 rows, or in this case, it could keep going and have, it could have 100 rows. Who knows? We're going to say in general that it has m rows. M is the number of rows in the matrix. So these are the rows, going, just like you'd think, going from left to right. These are the rows. The vertically aligned numbers we refer to as columns. And we can have as many columns as we want also. In this case, we have just n. We don't know what that is. It could be 100, it could be 1,000, it could be 1, it could be 3. Who knows? So that's what a matrix looks like. When we talk about the dimensions of a matrix, that's telling us how big it is, how many rows and how many columns do we have. So we always do the rows first and then the columns. Okay, rows, then columns. And we say that a matrix that has m rows and n columns, we'd say that's an m by n matrix. Okay, so what are the dimensions of that matrix, do you suppose? Yeah, 2 by 3, right? Because it's got 2 rows and 3 columns. And we do it's the number of rows by the number of columns. So that's a 2 by 3. What's that? Yeah, does that make sense? 3 by 3? 3 rows, 3 columns? What's that? 2 by 2? Oh, I gotta be careful. 2 by 1. Good. 2 rows. Each of the rows is pretty short. There's only 1 entry in each row, but there's 2 rows and 1 column. And what about that one? 1 by 2. 1 row, 2 columns. And then last, 1 by 1. Yeah, 1 row and 1 column. Pretty boring. Just got 1 entry. Okay. So how do we add and subtract matrices? Okay, first of all, to add matrices, we're just going to add the corresponding elements. We call those little parts of the matrices, we call those the elements, or the entries, either way. So to add them, we have to have the same, both of the matrices have to have the same dimensions or they wouldn't line up. We have to be able to add all the corresponding parts, but the corresponding parts all need to line up, so they need to be identical dimensions. So let's take these two, for example. What are the dimensions of those? 2 by 2, and they're both 2 by 2, so they add. Okay, if I want to add these up, all I'm going to do is just add the corresponding parts. So the row 1, column 1 part of this matrix gets added to the row 1, column 1 part of this matrix. Okay, so we just get -5 plus 6 we're gonna add up the 0 and the -3, etc. And we end up getting something like that. That make sense? Easy. That's all there is to it. All there is to it. Okay, so what am I gonna get here if I add a 0 matrix where all the elements are zeros? Is it gonna change anything? No. This is, by the way, this is the matrix version or the matrix equivalent of just adding the number 0. And I want you to kind of think about these things that way. As we do this arithmetic with matrices, kind of be thinking about it in parallel to the way you do arithmetic with just plain old real numbers. And there are going to be some correlations. So this is like the matrix version of 0. Okay. Add 0 to something, it stays the same. It's the additive identity. Okay. Okay, to subtract matrices, same idea, same exact thing. You're just going to, instead of adding corresponding parts, you're just subtracting corresponding parts. So what do you think you're going to get from this one? What's the row 1, column 1 entry going to be? Oh, and one thing I should have mentioned that I didn't. Let me show you one thing real quick. Remember in that first matrix that I pulled up that had all those, it had stuff like this? What do you suppose that 1 and 1 mean?
1 plus 1.
No. You have row 1, column 1, right? Row 1, column 1. So if I want to put one right here, it's going to be A sub what? 1, 2. Row 1, column 2, right? If I want to put one down, clear down here, let's say this is the 3rd row. What's this one right here going to be? Yeah, 3, 2, right? Row 3, column 2. Does that make sense? Okay, so that's how we name these things. So, given that, in my answer here that I get, you tell me what's going to be, if the answer is, we'll call it matrix A, what's A sub 2, 2 going to be in my answer? 0 minus 3. So it's going to be -3. Make sense? Okay, what's A sub 2, 3 going to be? So row 2, column 3. What's my answer going to be? Yeah, that element. No. Row 2. Oh, I'm sorry. You're right. You're right. Nothing. That's not going to work. Forget that one. How about this? 3, 2. -1 minus 3, which is what? -4. Good. Good. Okay, so that's what we get, right? Just subtract corresponding parts. Easy. Very simple. We could probably dispense with those. I think you guys have got this. Okay, so additive inverse of a matrix. So no big deal. It's a fancy word, but all it means, remember what the additive inverse means for numbers. The additive inverse is just opposite. That's all it is. Additive inverse just means I'm multiplying everything by -1. That's it. So the additive inverse of this matrix is just all of the elements multiplied by -1. Yes, ma'am.
Are we using it like 2A?
Yeah, that's coming up right now. Okay, so finding the additive inverse of that, really simple. It's going to be that, isn't it? Right? Okay? Scalar multiplication. That's what Amanda was talking about. Scalar multiplication just means if I've got a number outside the matrix next to it, well, when something's next to something in algebra, it means multiplication, right? It implies multiplication. So this is saying that the number k is being multiplied by this whole matrix. What do you suppose you do? Yeah, you just distribute it all the way through, exactly. So there it is. That's it. Okay, that's scalar multiplication. So what are we going to get from this one? What's row 1, column 1 entry going to be?
-3.
-9. Good. What's row 2, column 1 going to be? 12. Row 2, column 1, 3 times 4. Okay. Okay, now this is just what's different about this? Well, there's some variables in there. What do you suppose we're going to get for the row 1, column 3 entry when we do that scalar multiplication? 5x. 5x. No, just 5x. That's it. Oh, I said row 1, column 3, so that one's gonna be 5x. Down here, it would be 5x squared. The row 3, column 3 would be 5x squared. Yeah. Okay? So what that allows us to do then, it allows us to actually solve some equations that have, with matrices that have variables in them. That looks really complicated.
You just distribute two and add them to.
Yeah, all we're gonna do is just simplify the left side, and then I'm gonna get two matrices that are equal to each other, right? So first, before we go to the next step, let's just take care of the left side of the equation. Well, if I'm gonna do order of operations, like I normally would when I'm simplifying something, I'm gonna work inside the parentheses first, right? So inside the parentheses, I'm adding up these two matrices. So what am I gonna get for my first element, row 1, column 1? If I'm adding these two together. No. 3x plus 4. Because those aren't like terms. I can't combine them, but I'm still adding them up. Right? Now, negative 1 plus 1 equals 0. So those combine, right? So negative 1 plus 1 combines. 8 plus negative 2, those will combine to, and then I multiply, I got you. Those would combine to 6, right? These would combine, those don't combine, they're not like terms, right? So then I've got to distribute my 2 all the way through, do the scalar multiplication. So 2 times 6 is 12, 2 times 0 is 0, but 2 times the quantity, 3x plus 4, I have to distribute it, don't I? What that's really doing is something like this. That's really saying, when I distribute this guy there, that's equal to 2 times the quantity, 3x plus 4, which is 6x plus 8, right? Make sense? And when I distribute the 2 down here to this one, it's going to be 2 times the quantity 5 minus y, which is 10 minus 2y.
So you can only do it, or do you do?
Well, I'm going to multiply 2 by everything, but because when I multiply 2 by a quantity like this, I have to distribute. Okay, that's just what multiplication in that case means, is distribution. So, now what do you suppose I do from here? Once I've simplified the left side and got this, my right side I haven't done anything to. Okay, what do you mean by make them equal? Okay, so I've got some equations, right? And notice that the zeros, 0 equals 0, right? 12 equals 12. It has to be, right? Because if two matrices are equal, doesn't that just imply that all the parts of the matrices are the same? But then it also must mean that whatever 6x plus 8 is, that's got to equal 26, right? And whatever 10 minus 2y is, that's got to equal 8. So I get equations there that I can solve and find the values of x and y. Okay. So if I set those up, those are easy to solve. 6x plus 8 is 26. Subtract 8, divide by 6, and get x equals 3. My other equation, if I subtract 10, divide by negative 2, y equals 1. Okay. Okay, so last thing, and this, you're going to get the hang of this. This is just kind of getting a feel for it a little bit, but what can we do with these matrices then? Well, there are some properties that we're used to that work for matrices. If I've got, now think back to just when you're dealing with numbers, right, just real numbers. The associative property of addition, that just says if I'm adding up 3 numbers, for example, I can group those any way I want to. I could add the first 2, get an answer, and then add the third. And I should get the same thing as if I were to add the second 2 first, get an answer, and then add the first. Not going to make any difference. That's also true with matrices. If I'm adding up 3 matrices, I can group them however I want to. You got to add them in pairs, and it doesn't matter which pair I add first. The commutative property of addition also works, right? If I'm adding 2 numbers up, 3 plus 4 equals 4 plus 3, of course, right? Same thing is true with matrices. If I add up matrices, I can add them in any order I want to. Okay, distributive properties also work, as we've seen. I can distribute something over two matrices, just like that's fine to do. But I want you to, and we'll get some practice with that, but I want you to notice something here. We'll get to this later. Multiplication is not included. Okay, the properties, as we're going to see, the properties of multiplication for real numbers do not apply to matrices. For example, the associative property of multiplication and commutative property don't work for matrices. Because multiplication of matrices is just a little bit so. Okay. So how do we do this on a calculator? Let me show you the trick for doing this on a calculator. All we have to do, and I'll just go back to one of these prior examples here. What if we wanted to add up something simple like that? What if we just want to add those two matrices? Okay. Here's what we do. Get out your calculators. Okay, so clear everything. And while we're at it, let's go ahead and get out of inequality if you're in it. I don't know if I am or not. Let's see. I am. So I'm going to go apps, alpha, I. Remember, the way we get out of this, we just go to the program, and then it'll give us an exit menu. I think. Should. What did I do? Did I pick a different one? Yeah. Oh. I didn't really want to be in this one, so I'm going to quit. There we go. So once I go to inequality, I can just quit to, and I'm out. All right, so what we have to do here, notice that there is actually a matrix button on your calculator. It's behind the inverse button on the left side. So if I want to do stuff with matrices, I just have to hit second matrix, and it takes me to the matrix screen. Now there are three different menus on the matrix screen. There's the names menu, there's the math menu, and the edit menu. If we want to make a matrix, then we have to go to edit. So I'm going to scoot over. I can either scoot to the right by 2 or the left by 1 to get to the edit menu. And we're going to call this first one, how about matrix A? So I'm going to go ahead and hit enter because I want to edit matrix A. Now, first thing it does, notice it tells me matrix A, and it gives me the little brackets that indicate it's a matrix. And then it's got some dimensions up here. The default, I guess, is 1 by 1. But I don't want it to be a 1 by 1 in this case. I want it to be what? 2 by 2. So I'm just going to hit 2, enter, and it scoots me over to the next one. 2, enter, and look what it does. It builds a template, a 2 by 2 template for me. All I have to do is just fill in the blanks, fill in the entries. Now, what the calculator, and you want to do it this way, it's much easier. You want to just hit enter between each number. And to do that, it's gonna go from left to right across, just like you're reading a book. It's gonna go left to right across the first row, and then it'll skip down to the next row. So in this case, I would hit 4, enter, -1, enter. Then notice it scoots me down to the front of the next row. 6, enter, -3, enter. And now I've got it. There's matrix A. Okay, that one's done. So I can go ahead and go back to the matrix menu and create matrix B in the second one. So second matrix, go to edit. Now notice matrix A, it tells me it's 2 by 2. Okay, that tells me the dimension, and it tells me it's already in there. Okay, so I know I've created matrix A. So we'll go down to matrix B and hit enter. And 2 by 2 also, right? So make that a 2, enter, 2. And what, -6, enter, -5, enter, 7, enter, 3, okay? And now I can quit. Okay, so I've got them both in there. How do I add matrices? I have to pull up the matrices, so I just go second matrix. And then in the names menu, the first column, the first menu of that screen, this is where I can choose the matrices that I've built to do stuff with, like add. So I wanna pick number 1, so I can either hit 1 or enter, and it'll insert matrix A into the, the home screen. I'm just gonna add to that. Now I need to put matrix B in there. So I'll go second, matrix, scoot down, either push 2 or scoot down, and it puts a matrix B there. And if I hit enter, look what it does. There's my answer. Okay, I got that. Yes.
Can you go over that again?
Sure. Sure. So to put these in there, one more time, to put those in there, we're just gonna go second, matrix, edit. That's where I'm gonna put the stuff in, and then I just choose, I type the number corresponding to the matrix I wanna build. So if I wanted to build, let's build C. Let's say I wanna build matrix C, because I wanna show you something anyway. So I'm gonna build matrix C, but I'm gonna make the wrong dimensions. I'm gonna make this a 3x2. Okay, and I'm gonna make it pretty boring. I'm just gonna make all the entries 5. Okay, everybody see how we did that? Does that make sense? So that's how we put them in there. Now if I quit, I can like maybe add up A and C this time. So second matrix, whoops, hold on. Second matrix. So we're gonna add A plus matrix C. Think it's gonna like that? Wait, how come? Say it again? Okay, but I created C. How come it's not gonna like A plus C though? What do you think, Gabe? It's a 3x2. C is right. What did we say about adding matrices? You can only add matrices of the same dimensions. So if I try to do this, look what it tells me. What do you think that means? Dim mismatch. Dimension mismatch. Yeah, I tried to add 2 matrices that the dimensions don't line up. They had to be the same dimensions and they weren't. So it actually tells me kind of what I did wrong there. Let's try it. Well, it just what it does is it tells you that it clicks on it, it's beeping on C, telling you that C didn't match A. To fix it, all you have to do is just second matrix and edit it. Okay, does that make sense? Okay, I think, would you rather, I'll leave it up to you. Would you rather I show you how to multiply them right now, and then, or go to the lab now, and me do that to start class tomorrow? I don't care.
Go to lab. Go to lab.
Go to lab now. Okay, we'll take 10, 15 minutes and talk about multiplying them tomorrow.